Okay, what are the exterior angles of a polygon, and what is the sum of exterior angles of a polygon? I mean, how do we find that? So the big thing is first is just what are exterior angles of a polygon. So we'll start with a pretty simple one. We'll start with a triangle. These blue angles, those are interior angles. They're inside the polygon. If you kind of think of a pinwheel and you extend each line, each side out, it creates an exterior exterior angle of a polygon. And so I'll extend this one. There's your exterior angle. And I'll extend this one. There's your exterior angle. So those three angles combined, they're all three exterior angles of a polygon. Notice they always make a linear pair with the interior angles. And if you remember, hopefully you're to this point in your geometry where you know what a linear pair is. Linear pair, two angles that form to make a straight line, which a straight line is 180 degrees. So that's kind of a nice little property that we'll use later. So in this particular case, this is an equilateral triangle, so all of these angles are 60 degrees, all the interior angles, because you know the sum of the interior is 180 degrees. 180 divided by 3 is 60, which means the exterior, since this is a linear pair, all of these exteriors have to be 120 degrees. So, well, 120 times 3 is 360 degrees. Huh, interesting. So now let's look at kind of the situation more dynamically. So let's look at possibly, sorry, my cursor wasn't working. So let's look at a triangle here that I can shrink away. So I have my three angles marked. This one's 114, this one's 119, this is 128. You can change this triangle however you want. So it was 360 for an equilateral triangle. What about something that's scalene, for instance? This one's definitely not, none of the angles are equal in this one. And so let's shrink this triangle away and see what's left. Huh, look at that. It forms a circle, which if you add 164, 63, and 133, you get 360 degrees. So shrinking that away, and it does not matter how we change that triangle. So I'll shrink it away. Looky there. They add up to 360. And so we can do this in any number of triangles. There's 360. So excellent. Triangles looks like we haven't proven that the exterior angles of a triangle are 360, but looks like that's the case. There's probably some fancy algebraic proof that we will probably not pursue in this video, but we will eventually. So let's look at a quadrilateral. Is it the same? So let me kind of just rearrange that a little bit so you can see it better. And again, if you see this quadrilateral, notice I can change it however I want to. And the green angles are the exterior angles. And so let's shrink it away. This one dilates it to another place on the screen, so I'll do that. And there I'm shrinking it. And look at there. The four angles added together give you 360 degrees. And is that always the case, no matter what the thing looks like? So there it is, 360. So it doesn't matter. So it looks like that property holds even with quadrilaterals. Okay, yep, doggone, there's 360. Okay, so let's take it up a notch. Here's a pentagon. This one I can't quite fit on the screen, so you'll just have to be happy with the shape. not the slider. But again, this pentagon, I can change it to however I want to change it. Again, the green angles are exterior angles of the pentagon. And let's shrink it away. So we dilate that shape, and look at there. All 5 exteriors add up to 360. So you have to be wondering, is it the same for all polygons, no matter how many sides? So what if I had a 1,000,000-sided polygon? Do the exterior angles add up to 360 degrees? The answer to that question is yes, they do. And so here's where you'd have to probably set up a proof. We could do this algebraically. I'm not going to do that in this video, but definitely worth exploring further to look at the proof on why that is. And so there's the pentagon, and like I say, you can look at it however you want to look at it. Change it to whatever you want to change it to, and it'll still shrink to 360 when you get rid of the interior polygon. So let's use this property now. So if we have a polygon, and so let me just see if I have something. So let's just throw in something here. And so I think we have looks like an octagon. It is. So we have an octagon here. And what is each exterior angle of an octagon? So stop the video and see if you can figure this out. What are each of these angles? Okay, how many degrees? And so if you've stopped it, give it a shot, however you want to do that. But if we know that the sum of the exterior angles are 360, all we should have to do is take 360 divided by 8, as long as this is a regular polygon, which it is. So 360 divided by 8 is 45 degrees. So every single one of these exterior angles is 45 degrees. What's cool is by knowing that one fact, we now know what every interior angle of an octagon is equal to. And so every interior angle has to be 135 degrees, because it would be 180 minus 45, because that's a linear pair between these two, which is 135. And so we could find the sum of the interiors by taking that times the 8 angles that are all equal. Well, 135 times 8 is 1,080, which we knew if we used the formula n minus 2 times 180 from the interior sum of a triangle, because there's 8 sides minus 2, that's 6. 6 times 180 is 1,080. So that just shows you kind of the diversity of interior exterior angles, some of the formulas that go with it. Give yourself maybe one more practice, make sure you've got it. Here we go. This one won't come out even. So go ahead, try it, pause the video, see what that is. What's every exterior angle? What's every interior angle? See what you can come up with there. And then start it up and I'll show you the answer. Alright, so unless I counted wrong, this is a 16-gon. I don't know what the name of it is beyond 16-gon, but that's good enough for me. Exterior angle-wise, we know that they all have to add up to 360. So 360 divided by 16 will give you 22.5 degrees. So every single one of these, and I'll see if I can draw a straight line here. So that angle right there is 22.5 degrees. That angle is 22.5 degrees. And so if you continued that around, you'd have enough to make up 360 degrees with them. The interior, that means each of these interior angles is 180 minus 22.5, which would be 157.5. So every single angle in this regular 16-gon is 157.5 degrees. So maybe I'll have time later. I mean, this would get you through most geometry lessons.